We're on lesson 6.3, page 162, comparing ratios. You can use equivalent ratios to solve real-world problems. Example 1 is just an example on how to solve one of these problems. I'll read that with you and kind of help you examine it, and then there's a your turn at the bottom of the page. You'll pause the video, try it, and then resume the video to check your answers. Example 1. A fruit and nut bar recipe calls for 4 cups of chopped nuts and 6 cups of dried fruit. When Tanya made a batch of these bars, she used 6 cups of chopped nuts and 9 cups of dried fruit. Did Tanya use the correct ratio of nuts to fruit? So they give her a recipe which she didn't follow exactly, but did she use the right ratio? So notice that the numbers here, 4 cups of nuts and 6 cups of dried fruit, were written right here as a fraction, 4 cups of nuts over 6 cups of dried fruit. And then what Tanya used was 6 cups of nuts and 9 cups of fruit, and that's written right here. And the question is, I'm going to do this off to the side. The question is 4 to 6 equal to 6 to 9? So some kids would look at this 4 to 6 and 6 to 9, and they might think to themselves, well, you can't multiply 4 by a whole number to get to 6, and you can't multiply 6 by a whole number to get to 9. And you can't, that's true. So we're going to have to think of this a different way, because that doesn't, just because you can't multiply it by a whole number, doesn't mean it's not true. So pay attention to what the directions say down at step number 3. It says find equivalent ratios that have the same second term. So what that means is, could you multiply 6 and 9 each by a number to get the same number? And this goes back to what we learned in Module 2, which is about multiples. 18 is a multiple of both 6 and 9. In other words, if I did 6 times 3, I would get 18. And if I did 9 times 2, I would get 18. So what that's saying is, if you triple this recipe and you double this recipe, you end up with 6 times 3 is 18, 4 times 3 is 12. And if you double this recipe, 9 times 2 is 18, 6 times 2 is 12. You end up with all the same terms. You get a ratio of 12 to 18 and 12 to 18. So ultimately the answer is yes, they are equivalent. I actually want to show you one other way that you could look at this. I'm going to go ahead and make a little bit of white space here. And I want to show you something that Moby taught you. It's called cross products. So let's go back to, let's pretend we didn't have any of this information except for the directions. And the question said something to the effect of, you need 4 cups of chopped nuts and 6 cups of dried fruit. So I'm going to use initials to keep that straight. And then Tanya used 6 cups of nuts and 9 cups of dried fruit. And really, you probably shouldn't write an equal sign, because the question is, are they equivalent? So you should put an equal sign and a question mark, because I don't know if they're equivalent. But I want to show you an easy way to look at this. It's called cross multiplication. Cross multiplication means that if you multiply diagonally this way and this way, if the products are equal, then the rates or ratios are equivalent. Diagonally one way, 6 times 6 is 36. Diagonally the other way, 4 times 9 is 36. Since 36 is equal to 36, then that again answers the question. The answer is yes, those rates are equivalent. Now, if I checked that diagonally and they were not equal to each other, then that would mean that those ratios were not equal to each other. All right, let's go ahead and go down to the bottom of the page and try the your turn. I would like for you to read and try question number 2 on your own, and then resume the video when you are ready to check your answer. This is the your turn at the bottom of page 162. I will read it with you, I will set it up, and I have a feeling you'll get the correct answer faster than I can explain it. Number 2. In the science club, there are 2 6th graders for every 3 7th graders. At this year's science fair, there were 7 projects by 6th graders for every 12 projects by 7th graders. Is the ratio of 6th graders to 7th graders in the science club equivalent to the ratio of science fair projects by 6th graders to projects by 7th graders? Explain. It's a pretty good chance that upon first reading that you are a little overwhelmed and maybe not even sure what that asks. So one strategy is to reread it. Another strategy is just to start setting stuff up. For example, I'm going to go through and kind of highlight some numbers. It says there are 2 6th graders for every 3 7th graders. So you could set that up just like you did above as a fraction. Maybe what I'll do is I'll put a label off to the side where I'm going to put my 6th graders first and my 7th grader second. And the reason why I chose 6th graders first is because that came first. Look at that term, 6th graders to 7th graders, and the ratio is 2 to 3. So there are 2 6th graders. Notice I'm pointing 2 6th graders for every 3 7th graders. And then later in the question at the very end, it says, is the ratio equivalent? So I'm trying to find out if this number, 2 to 3, is going to be equal to another number. I just need to go find those other numbers. If I read this sentence right here, at this year's science fair, there were 7 projects by 6th graders. I'm going to put that on my top term because my 6th graders are my top term. And then it says for every 12 project by the 7th graders. So that's going to be my second term. So really what this is asking now, if I want to get rid of some of this stuff, really what this is asking now is 2/3, I'll reread it right here, nice and neat, is 2/3 equal to 7/12? And there are lots of ways to check this. One, you could do that cross products thing I just showed you. 2 times 12, or 2 times 12 is 24. Is that equal to 3 times 7? Well, 3 times 7 is 21. Is 24 equal to 21? It is not. It's not equal, so that means the answer is no. These ratios are not equivalent. So I could just, that's one way I could solve it. I'm going to go ahead and finish my sentence, not equivalent. It says explain, but honestly your work being shown is an explanation. That's not the only way to solve it though. I could have got back down here. I'm going to go ahead and erase a little bit. And let's pretend I'm not as comfortable with cross products because it's brand new. So let's pretend I just have this right here. And again, I'm trying to figure out if these things are equal. So I put a question mark. I could do it this way. To increase my second term from 3 to 12, I would multiply by 4. And by now, I hope you know that when you multiply one term by 4, you have to multiply the other term by 4. And is 2 times 4 equal to 7? It is not. So it's the second time I've proven that this is not equivalent. So you can either use the cross products, or you could use that method that I just showed you right there, which is to multiply.